Good morning everybody. In this class we will discuss about the lasers. What do you mean by laser? Actually laser is the short name of light amplification by stimulated emission of radiation. Light amplification. What do you mean by light amplification? Light amplification means when we get high intense light from low intense light. That means intensity of the light is enhanced. We get high intense light using very small intense light, and this is the light amplification. And the term stimulated emission of radiation. Actually, stimulated emission of radiation is responsible for the amplification of light. That means to produce the laser light. So stimulated emission of radiation is very important in laser light. What is stimulated emission of radiation? Let's see. There are two energy levels in a system. It is lower energy state, it is also called ground state, and this is energy state, and it is one of the excited state of the system. And if the atom initially remain in the ground state, means lower state, and if photon of energy h nu equal to E2 minus U1 incident on the system, then this photon will be absorbed by the atom, and atom goes to the excited state. Okay, so this is called absorption of radiation. Okay. In the excited state, the lifetime of atoms is not very high. They do not stay very long period of time in the excited state. About 10 to the power minus 8 seconds they stay in the excited state. Okay. After 10 to the power minus 8 seconds, automatically come down into the lower state, and after de-excitation, a photon will be released having energy h nu is equal to E2 minus E1, or E2 minus E1 is the frequency of the emitted photon, and this is called the spontaneous emission of radiation. Spontaneous emission of radiation. Okay, this is the spontaneous emission of radiation. Most important is the stimulated emission of radiation. When the atom initially remains in the excited state, before excitation, if a photon of energy h nu equal to the difference between the two energy state incident on the substance, then the photon under the action of the electromagnetic field of the incident photon come down into the lower state and released an additional photon with the incident photon. So, in that case, actually this photon by force stimulate to de-excite the atoms, and here two photons will be released. One is incident photon and another one due to the de-excitation of the excited atom. So due to the one incident photons, we will get two photons having same frequency, same energy. They move in the same direction, having same phase and also same state of polarization. Okay, so this is the stimulated emission of radiation, and this is responsible for the light amplification. Okay, now I will discuss the basic components of the laser. The basic components of the laser are active medium, it is also called the amplifying medium. Active medium consists of collection of atoms, collection of molecules or ions. When the active medium is a collection of atoms, then this type of laser, actually depending on the active medium, or lasers are classified different categories. When the active medium is a collection of atoms, then it is called atomic laser. Okay, and helium neon laser is the example of the atomic laser, because here the energy levels of the neon atoms are used to develop the laser light. Okay, so this is the atomic lasers. If the active medium is consist of collection of molecules, then this is the molecular laser. And carbon dioxide laser is the example of the molecular laser, and here different energy levels of the carbon dioxide molecules are used to develop the laser light. Ionic laser, an example is argon ion. Here argon ions, ionic laser, actually argon ion laser, here the energy levels of the argon ions are used for the lasing action, and depending on the state of the substance, the state of the substance of the active mediums, lasers are also classified into different categories, such as gas lasers. When the active medium is gaseous medium is used for the lasing action, then the laser is called the gas laser, and helium neon laser is the gas laser, carbon dioxide laser is also the gas laser, argon ion laser is also the example of the gas laser. All these are the gaseous lasers. If the active medium is solid state, then this is the solid state laser, and ruby laser is the example of the solid state lasers. If the active medium is used liquid state, then this is the liquid laser, and dye laser is the example of the liquid laser. And if we use semiconductor materials as active medium, then it is called semiconductor laser. And there are different semiconductor lasers, gallium arsenide, indium phosphide, different types of semiconductor lasers are there. Okay. Now I will discuss population inversion. Pumping mechanism. pumping mechanism. What is pumping mechanism? Actually, pumping mechanism is a process to achieve a population inversion. Population inversion is very important to produce laser light. Suppose there are two energy states, E1 and E2, and the number of atoms in the lower state, that means in the E1 state, is the N1, and the number of atoms in the higher state, that means in the E2 state, is the N2. In normal state, normal condition, the number of atoms in the lower state is always greater than the number of atoms in the higher state. This is the normal condition. That means the lower energy state is highly populated than the higher energy state. This is the normal condition. But if certain condition, the number of atoms in the higher state is greater than the number of atoms in the lower state, that means the higher state is highly populated than the lower state. So population is inverted. This is the population inversion condition. Okay. But for two energy levels, population inversion is not possible, because we know the excitation of atoms from lower state to excited state and de-excitation, rate of excitation from lower state to higher state, and rate of de-excitation from higher state to lower state are same. So maximum population will be in the higher state is 50%. That means, and also in the 50%. So their population inversion is not possible. So two level laser system is also not possible. At least three level required to produce a laser light. Otherwise, population inversion is not possible. Another important thing for the population population inversion, metastable state is required. Metastable state is required for the population inversion. Without metastable state, the population inversion is not possible. For a normal excited state, suppose E2 is the energy state, and for normally the lifetime of the atoms, please keep in mind one thing, the excitation of atom or excitation of electron are same thing. Suppose a atom, this is the nucleus, and electrons are revolving around the nucleus in different orbit. Okay. In a normal state of the atom has certain value of energy, and if a electron excited from this state to this state, that means the electron is excited. In the same time, the energy of the atom also increased. With increasing the energy of the electrons, atom energy also increases. So the excitation of the electrons and excitation of the atom are same thing. Okay. Now I want to discuss about the metastable state. For a normal excited state, the lifetime is very smaller, 10 to the power minus 8 seconds. But there are few energy states where the lifetime of the atoms are very high with respect to this, and about 10 to the power minus 4 to 10 to the power minus 3 seconds. Almost 10 to the power 4 times greater than the normal excited state. And this type of states are called the metastable state, and this type of state is used to achieve the population inversion. Okay, so metastable state is also very important to achieve the population inversion, and pumping mechanism is also very important. there are different type of pumping mechanism. Optical pumping, electrical discharge, inelastic, atom collision, and chemical pumping. Okay, these are the type of pumping mechanism and etc. There are also, but these are the popular pumping mechanism, but most important pumping mechanism are optical pumping and electrical pumping. Okay. In optical pumping, light is used for the pumping, light energy is used, and in electrical pumping, electron is used for the excitation. In optical source, light emitted from band. Okay, so optical pumping is used in those cases where the energy bands are used for the lasing action, where the energy levels are used for the lasing action. These are the energy bands. In case of solid state laser, we know in case of solid state there is band, energy band, and energy bands are participate for the lasing action. And in that case, optical pumping is the most efficient pumping. And also in the liquid laser, the optical pumping is the efficient pumping mechanism. Sometimes in the semiconductor laser is also pumped by optical pumping. And second one is the electrical discharge. Here a strong electric field is applied by using very high voltage source, and the active medium is placed in the electric field, and when the electrons are accelerated by the electric field and cross the active medium, they collide with the atoms or molecules or ions in the active medium, and the energy of the electrons transferred to the atoms, molecules or ions, and they excited to the high state. So here electrons is used for the excitation. Okay, so and when we will use the electrical discharge pumping are used when the energy levels are very sharp, and we know in case of gas the energy levels of the atoms are very sharp, and so in case of gaseous laser, electrical discharge is used for pumping. Okay. Now another is the inelastic atom-atom collision. Inelastic atom-atom collision, if we consider the helium-neon laser. In helium-neon laser, the energy levels of the neons are used for the lasing actions, and here helium is used for the pumping the neon to excite the neon atoms into the metastable state of the neon. Why? Here we will use the helium, not other atoms, because the metastable states of the helium are approximately close to the metastable state of the neons, and also the helium atom is lighter in mass with respect to the neon atom. So we can easily excite the helium atom to the metastate of the helium atom, and excited helium atom when collide with the neon atoms at the ground state, then easily we can pump the neon atoms to the metastable state of the neon atom. So this process is a very efficient pumping mechanism, inelastic atom-atom collision. Here the excited helium atom when collide with the neon atom in the ground state, the neon atom goes to the excited state and helium atom come down into the lower state. So this is another technique for pumping, inelastic atom-atom collision. Now chemical pumping, in chemical pumping, chemical reaction is used for pump the medium. Okay. Now, another basic components of the laser is the resonator cavity. What is resonator cavity? Actually, resonator cavity is it consists of two parallel mirrors placed face to face. One of the mirrors having reflectivity 100%, it reflects 100%, and another one less than 100%, almost 90%. And this partially reflected mirror gives the output, and the active medium is placed in the resonator cavity. Due to the spontaneous emission, if few number of photons are moving along the axis, suppose here 100 photons are moving along the axis of the tube. So due to the stimulated emission of radiation, due to these photons, here almost 200 photon will be developed. 100 incident photon and 100 due to the de-excitation of the atom. So almost 200 photons will be developed. Okay, and 90% of 200 photon will be reflected back by this mirror. Okay, and 10% we will get as a output. And again, the photon follow this path and again reflect by this path, and they continuously moving back and forth and continuously produce output as a laser light. So the resonator cavity produce a continuous laser light, and it is also called positive feedback amplifier to sustain the continuous laser oscillation, and we get continuously laser light. Okay, thank you.